Okie dokie, we are back with part 2 of our Unit 3 practice test review. Alright, so let's go ahead and just get started with number 7. Alright, Janice is going on vacation and needs to leave her dog at a kennel. Nguyen's kennel charges $15 per day plus $20 for a processing fee. The Pup Palace charges $12 per day and has a $35 processing fee. After how many days is the Pup Palace kennel cheaper than Nguyen's kennel? Okay. So, pretty much this is true for every kind of problem. If you have a higher per day and a cheaper fee, like if what you're charging over and over again is higher, then it's going to eventually be more expensive than the one that's lower, even if it has a lower upfront fee. So usually what happens is this one, the one that's got the higher daily but the lower upfront fee, it's cheaper for a certain amount of time, but after they hit that point where they're the same, the one that has the lower daily and the higher upfront fee is going to eventually be less expensive. So if you need it for a short amount of time, you always go with the one that's got the lower fee. If you need it for a long amount of time, you go with the one that's got the lower daily cost. And again, that's why this is kind of important. People actually do need to find that point where you break even and figure out where you fall so that you don't spend more money than you need to. That said, if I'm leaving my puppy somewhere, I want my puppy to be in a safe place, so I don't care how much it costs. Just saying. Okay, so for my first kennel, we'll do Y equals, it's $15 per day, so we'll do 15x, plus a $20 processing fee, so plus 20. Okay, Pup Palace is going to be the same setup. It's going to be Y equals, it's $12 a day, so 12x, plus the $35 fee. Okay, again, this is an easy one to do substitution on. This is an easy one to do to graph. I don't have a graph on me though, so we'll do substitution. So since y is equal to 12x plus 3, I can replace the y here with that 12x plus 3. And that would look like this. 12x plus 3 equals 15x plus 20. Okay, so you want to try to get your x's together and just have one set of x's that you're dealing with. So you're going to have to either subtract 12x from both sides or 15x from both sides. Doesn't matter which way you choose. However, my suggestion is to always move the smaller of the two numbers because then you have less of a chance of dealing with negatives. I'm not going to say you never deal with negatives, but you don't have to deal with them as much. So I've got 3 equals 15x minus 12x is 3x plus 20. Sorry, this is 35. I dropped my 5. I was like, that doesn't make sense. So now we'll subtract our 20 from both sides. That cancels, and I have 15 is equal to 3x. Divide both sides by 3. X is equal to 5. Okay. So x is equal to 5. This is the number of days at which they both cost the same. So after 5 days, Pup Palace should be cheaper. So I don't even need to figure out the cost because the question just asked after how many days is it cheaper. So we're going to say Pup Palace is the cheaper option after 5 days. All right. Number 8. This says solve for x. So we could do this a few ways. I'm looking at this. You could graph it. I wouldn't want to graph it. I'm actually not 100% sure why there's a graph here, because this is not an easy one to graph. I don't think. No, it wouldn't be, because we don't have a easy y-intercept for either of these. Okay, so you could do substitution or elimination. It really just depends on how you want to approach this. And we don't need a y value, but I think this is going to be less work if we go ahead and get the y value. So I'm going to do this on a separate sheet of paper since I've got that graph in the way. I was using an index card. So if I look at this, if you remember, elimination is where you eliminate, you add your two equations in a way that will eliminate one of your variables. So if I look, I have x and negative x. So I don't even have to change my equations. I can just simply eliminate that here. So why don't we go ahead and do that? So negative x and x is 0. Those are eliminated. 6y and 3y is going to be a total of 9y. And negative 4x and negative 35, I'm sorry, negative 46 and negative 35. 46 and 35, let's see, is going to be negative 81. So to solve for y, we'll divide both sides by 9, and y equals negative 81. So then I need to solve for x, since it's really just asking for x anyway. So to solve for x, I'm going to take this negative 81 and plug it in for y. Negative 9. Y'all, I don't think I'm going to finish the whole review today. I think I'm going to, after this page, take a break and come back. So, y is equal to negative 9. I'm going to take this negative 9 and plug it in for y in one of these two equations. So we have, I think I'm going to plug it into this bottom equation. So that would be x plus 3y, but instead of y, we have negative 9. That's going to equal negative 35. Okay? 3 times negative 9 is negative 27. We're going to add 27 to each side. And x is going to equal, let's see, 35 minus 27, negative 8. So x is going to equal negative 8. So solving it for x, I guess you could, I don't know. If you graphed it, your point would have been right here. So I guess you could have graphed it. That just doesn't seem like a lot of fun. Okay. Alright, so let's try number 9. Number 9 asks us to solve the system by substitution. So I have that y equals x plus 4. I can replace the y in here with x plus 4. And so I'm going to have 2x plus x plus 4 equals negative 5. I can combine like terms. I want to try to isolate x, so we'll subtract 4 from either side. 3x equals negative 9. We'll divide by 3. And x is going to equal negative 3. Okay. I also need my y value, so I'm going to go back to that bottom equation. That's y equals x, which is negative 3. Plus 4. Negative 3 plus 4 is 1, so y equals 1. Alright, so then it says to express your answer as an ordered pair. So my ordered pair would be negative 3, 1. Alright, number 10 is going to work almost exactly the same as we did number 9. We have what y equals. We're going to substitute that in for y, which means I'm going to have 5x plus y, but instead of y, we'll have x plus 3. And this is going to equal negative 3. 5x plus x is 6x. So I have 6x plus 3 is equal to negative 3. We'll subtract 3 from each side. 6x equals negative 6. We'll divide both sides by 6. X equals negative 1. Okay, so I'm going to take this negative 1 and we'll place it into my equation to solve for y. Y equals, instead of x, negative 1 plus 3. And negative 1 plus 3 is 2, so y is equal to 2. As an ordered pair, that is 1, 2. Okay. All right, let's take care of 11 and 12. All right, 11 asks us to use elimination. So first thing I'm going to do is see what's going to be the easiest thing to eliminate. I have a positive and negative x, and I also have a positive and negative y. So let's look at the numbers in front of it. These both already have a 2 in front. If I wanted to eliminate x's, I'd have to multiply the bottom equation by 2. And so let's go with the easier route and just eliminate y's. So I'm going to add my equations together. 4x plus negative 2x is going to be 2x. Negative 2y and positive 2y cancel. And this is going to be equal to 28 plus negative 12. And that should be 16. We'll divide both sides by 2, and x is going to equal 8. Okay, so to get my y value, I know what x is. I can plug it into either the top or bottom equation. Let me plug it into the top equation. And I have 4 times 8 minus 2y equals 28. 4 times 8 is 32. And so it's going to be 32 minus 2y equals 28. We'll subtract the 32 from each side, and that gives me negative 2y equals negative 4. Divide both sides by negative 2, and y equals 2. As an ordered pair, my solution is 8, 2. All right, number 12. We're going to solve the system by elimination. So, again, we're going to look at what's easier to eliminate. I don't have a positive and negative variable. All of my variables are positive. So I'm going to have to multiply one of my equations by some sort of negative number. If I wanted to eliminate x's, I would have to multiply the top equation by negative 2, and they would eliminate. If I wanted to eliminate y's, on the other hand, it wouldn't matter. I could eliminate either. I could multiply either by a negative and then just eliminate the y's altogether, because one's got a positive 3, one's got a negative 3. That said, I'm just going to show you what it looks like to multiply by a negative number. So we'll multiply the top equation by negative 2 to cancel the x's. And I'm going to multiply all 3 terms by that negative 2. So my new equation is going to be negative 2x minus 6y equals positive 22. Because negative 2 times negative 11 should give me a positive. And then I'm just going to bring this 2x plus 3y equals 5 down. Alright, so negative 2x, positive 2x cancels. Negative 6y plus 3y is negative 3y. 22 plus 5 is going to be 27. To get y by itself, we'll divide by negative 3. And y is going to equal negative 9. Alright, to solve for x, I'm going to plug negative 9 in for y. You can do it into either equation. I would suggest going with the first equation because we're solving for x. There's no variable in front of x, so I won't have to divide later, and that looks a little easier. So we'll do x plus 3. Instead of writing y, we'll multiply by negative 9. And that's going to equal negative 11. Okay, 3 times negative 9 is going to be negative 27. and this is going to equal negative 11 again. I'm going to add 27 to each side, and x is going to equal 16. As an ordered pair, my solution is 16, negative 9. Okay. Number 13, we have a system here, and we need to solve by elimination. And if I look at these, 3x and 5x are both positive. 2y and 3y, one's positive, one's negative. They don't have that nice where I can just go ahead and eliminate. I'm going to have to multiply. And I'm going to have to multiply both equations by some number. So if I look, 3 and 5 both go into 15. 2 and 3 both go into 6. That's a smaller number to work with. That's what I'm going to shoot for. I'm going to shoot for eliminating y's. Also, y, there's a positive and a negative y, so I want to eliminate that anyway. Alright, so in order to multiply and get this 2 to become a 6, I'm going to have to multiply by 3. And same here, in order to make this 3 a 6, I'm going to have to multiply the equation by 2. So I'm going to multiply the top equation by 3. 3 times 3x is 9x. 3 times 2y is 6y. 3 times 1 is 3. We'll do the bottom equation. 2 times 5x is 10x. 2 times negative 3y is negative 6y. And 2 times 8 is 16. Okay. We'll start working on eliminating. We're going to add our equations together. 9 and 10 is 19. Positive 6 and negative 6 cancels. 3 and 16 is 19. And then we'll divide both sides by 19. And x is going to equal 1. Alright, then solving for y. Again, you can plug x into either the top or the bottom equation. It doesn't matter. Again, I think the top is an easier equation to work with this time. So I'll change this x to a 1. So I've got 3 times 1 plus 2y is equal to 1. 3 times 1 is 3, so 3 plus 2y equals 1. If I subtract 3, I get 2y equals negative 2. If I divide by 2, y equals negative 1. And then as an ordered pair, my solution is 1, negative 1. Alright, last problem on this page, and then I'll stop this recording. At a local pet store, zebrafish cost $2.15 each, and neon tetras cost $1.80 each. If Yumi bought 15 fish for a total cost of $29.80, not including tax, how many of each type of fish did she buy? Alright, so again, we don't have to do substitution or elimination or graph. You get to pick. I think this one's going to lend itself to elimination, but it shouldn't matter. So we'll do Z for zebrafish, and we'll do T for tetras. Or you can do N for neon, I don't care. Or you can do X and Y. Alright, so we know she bought 15 fish, so she bought some zebrafish, she bought some tetras, and that was a total of 15 fish. So the zebrafish cost $2.15 each, so we'll do $2.15Z. Plus the tetras cost $1.80, so $1.80T. And her total was $29.80. Okay, so you could easily do substitution or elimination here. I think I'm going to go with substitution. So I'm going to look at this top equation and solve it. You can solve it for Z or T. I think I'm going to get Z by itself, which means I'm going to subtract the T from each side. And so Z is going to equal 15 minus T. And I'm going to plug 15 minus T in for the Z here. So I'll have 215 times z, but instead of z, it's 15 minus t plus 180t equals 2980. So we're going to do 215 times 15. That's going to be $32.25 minus 215t plus, and bring back down that 180t, and that equals our 2980. Okay, we're going to combine our like terms. So 180 minus 215 is going to be negative 0.35. Sorry, that should be 1.80. Yeah, negative 35. So we have 32.25 minus 0.35 t equals 2980. I'm going to subtract the 32.25 from each side. So 2980 minus 32.25. And that's going to give me 0.35t equals negative 2.45. And divide that by 0.35. I'm going to divide both sides by 0.35. Or by negative 0.35. And I get t equals 7. Which means she bought 7 of the Tetra fish. Okay, so how would I find, I'm ran out of room, but how would I find z? Well, I could take this 7 and plug it in for t right here. Z plus 7 is going to equal 15. So you can subtract the 7 from both sides, and z is going to have to equal 8. So, I ran out of room, but we can put it at the very bottom. She bought 7 tetras and 8 zebras, or zebra fishes. I don't know. All right, so we're going to stop here. We are about halfway through the unit test. And yeah, I'm going to stop it here. Y'all have a good evening, and I'll see you soon.